Hello students. So today we will solve some 1 or 2 marks questions asked in the board exam. Okay. So you can practice them. So the question is, if the vectors A 2i plus j plus k and B I plus lambda j minus 3k are perpendicular, then you have to find lambda. Okay, so perpendicular meaning what? The angle between them is 90 degree. Okay. So you can use our cos theta formula, that is for the dot product. Cos theta equal to A dot B upon magnitude of A and magnitude of B, right? So here perpendicular is given. So cos 90 is 0. Okay, so our dot product is 0. A dot B. Okay, so we have to find A dot B. I'll directly write. Okay. Don't have to write all these things. If it is MCQ, you can directly take the dot product and equate it to 0. So 2 plus 1 lambda minus 3 equal to 0. So this is 2 minus 3. Lambda is equal to 1. Okay. Next question, if A and B are two vectors such that A is minus I plus 3j plus k and B is I plus 2j plus 5k, you have to find the vector perpendicular to A and B. So in the cross product concept, we have seen that the vector which is perpendicular to A and B is the normal vector, right? That is the unit vector. So we have to find the unit vector. That is, we have to first take the cross product. Okay. Then you have to find unit vector. So cross product A cross B is given by the determinant. Okay. Minus 1, 3, 1, 2, 5. Minus 2 minus j minus 5 minus 1 minus 2 minus 3. So 15 minus 2, 13i minus 6 plus 6j minus 6k. Okay, this is our A cross B. So we have to find our normal vector, that is unit vector perpendicular. It is given by A cross B upon magnitude of A cross B. Okay, 13i plus 6j minus 6k on magnitude of A cross B is 13 square, 6 square, 6 square. Okay. 6, 241. So the numerator remains same and denominator is root of 241. Okay. Next question, if A dot B is given, magnitude of A and magnitude of B is given, you have to find the angle between A and B. Okay, so A dot B is given, so you have to take cos theta. 3 upon root 3 into 2. Okay, so we don't have this type of value, right? So we have to remove this root 3. So I'll multiply by root 3 in the numerator and denominator. So this will become, so this is actually root 3 by 2. So theta is cos inverse of root 3 by 2. Okay, cos of which angle is root 3 by 2? 30 degrees. So theta is 30 degrees. Okay. Next question. If magnitude of A is given, magnitude of B is given, and magnitude of A cross B is given, you have to find magnitude of A dot B. Okay. So we know that now there is no direct formula to find this, right? But we know the information, that is cos theta is A dot B upon A into B, and sin theta is A cross B, magnitude of A cross B upon magnitude of A, magnitude of B. Okay, so we have this value, these values. Okay, from this I can write this is common, right? So this becomes A dot B upon cos theta. This is a scalar quantity, so we can write here mod. Then this is A cross B upon sin theta. Okay, so these two values are same because the A and B vectors are same. So we can equate this two. So A dot B cos theta equal to A cross B mod sin theta. Okay, so I'll take this cos theta this side. Okay, now we can find our sin theta value using this. Okay, because this is given 8 upon 2 into 5, which is 10, right? So we can write here 4 by 5. So sin theta using triangle method, it is 4 upon 5. So opposite upon hypotenuse. So this is a triplet, Pythagorean triplet. So this value is 3. Okay. So cos theta is what? Cos theta is 3 upon 5. So we have to substitute it here. Okay. A cross B is given 8. Sin theta is 4 upon 5. And cos theta is 3 upon 5. So I'll take this here. So our answer is 6. A dot. Okay. Next question, you have to find the derivative of sine inverse of x with respect to cos inverse of x. Cos inverse of root of 1 minus x square. So this means that you have to find derivative of both with respect to x. Okay. And then you have to take this with this. That is, you have to write, suppose this you take as u, this you take as v. Then you have to write du by dv. That is derivative of u with respect to v you are doing. Okay. So to find this, you have to first find du by dx and dv by dx. So our u is sine inverse of x. So du by dx is 1 upon root of 1 minus x square. Okay. What about v? V is cos inverse root of 1 minus x square. Okay, so dv by dx is cos inverse of this. So it will be 1 upon minus 1 upon root of 1 minus, you have to take this square. That is, this is our x now, right? Square into derivative of this. This is 1 upon 2 root 1 minus x square into derivative of 1 minus x square. So it will be minus 2x. Okay. So this minus and this minus gets cancelled. This 2 and 2 also gets cancelled. Okay. This we can solve, that is root square. So this root also go. Okay. So taking minus inside, you will get here minus and here plus. So this one also vanishes. So 1 upon root of x square is x. root of 1 minus x square into x. So this x also cancels. So now we can write du by dv. So du by dx upon dv by dx. So du by dv is 1 upon root of 1 minus x square divided by 1 upon root of 1 minus x square. So this becomes 1 minus x square upon 1. So the final answer is 1. Okay. Next question. If y is log of root x plus root x minus a, you have to find dy by dx. Now remember here, a derivative of root x is, you can write this as x raised to half, right? So this becomes using x raised to n formula for a derivative, that is n into x raised to n minus 1, right? So this becomes x raised to 1 half minus 1, so minus half. That's why it is 2 root x. Okay, so whenever you have root, you can directly write 1 upon 2, that under root thing. Okay, so dy by dx, here log and this function is given. So first you have to write derivative of log of something. So it is 1 upon that something. Okay, into, now derivative of this thing. This is plus is given in between. So root of x is 1 upon 2 root x plus 1 upon 2 root x minus a into derivative of this. So derivative of x is 1, derivative of a is 0. So here 1 comes. No need to write. So this 2 I can take outside. Okay. So here you can cross multiply. So this gets cancelled. And finally you will get half 1 upon x into x minus. Okay. Next question, here x and y is given. So you have to find dy by dx. Parametric, this belongs to parametric equations. That is, you have to first find dx by dt and dy by dt. So I'll directly write dy by dt divided by dx by dt. Okay. So dy by dt, derivative of x, sine inverse of t is 1 upon root of 1 minus t square. Then, sorry, first you have to write y. So this becomes 1 upon 1 minus t square into log derivative of this function, that is this is 0, this is minus 2t upon this is root of 1 minus t square. Okay. So this goes in the numerator, so this is 1 minus t square. 1 minus t square into minus 2t. Okay. Now I can multiply by root of 1 minus t square in the numerator and denominator. So that this becomes 1 minus t square, right? So you will get final minus 2t upon root of 1 minus t square. Now you substitute your t equal to half. So minus 2 into half upon root of 1 minus half square. So 1 upon 4. So this is minus 1 upon 4 minus 1, 3 upon 4. This is 2. It comes in the numerator. So minus 2 upon root. This is our dy by dx. So you have to find the length of the perpendicular from point to the plane. So here you have to use the distance formula, that is distance d equal to ax1 plus by1 plus cz1 minus d upon root of a square plus b square plus c square. Okay. So here your x1, y1, z1 is this point, and a, b, c are this a, b, and c, and this is d. Okay. So we'll write 6 into 3 plus minus 3 into y1 4 plus 2 into minus 2 minus d is our 11 minus 11. So a square b square and c square. 18 13 49. So this is 7 and this is 16 2 13 units. 13 by 7. One small correction here, that is our plane is given in the form ax plus by plus 2c plus d equal to 0, right? So you have to take that plane in the general form, that is standard form, ax plus by plus cz equal to d. Okay, so our plane becomes 6x minus 3y plus 2z equal to 11. So our d is 11, not minus 11. Okay, sorry for this. So this is plus 11 minus 11. Okay. So you can write here minus. So this is 2 minus 11. So minus 9. So it becomes 9. Okay. It is in the mod, so it is positive 9. Right. Next question, you have to find the integrating factor of differential equation dy by dx x log x plus y equal to 2 log x. So first you have to write that differential equation in the standard form, that is dy by dx plus py equal to q, right? So here x log x is there, so you have to divide by x log x throughout the equation. So we'll get dy by dx plus y upon x log x equal to 2 log x upon x log x. Okay, so you'll get 2 by x. So our p is 1 upon x log x. Our q is 2 by x. So we have to just find the integrating factor. Integrating factor is given by e raised to integral p dx. Correct? P is 1 upon x log x dx. Okay, now you have to integrate. Now this integration can be done by using substitution. Okay. So we have 1 by x and log of x. Okay. So we can take u is log x and derivative we will get 1 upon x dx. So you have to substitute here e raised to integral u 1 upon u 1 upon x dx is du. Okay, so we get e raised to 1 upon u, integral of 1 upon u is log u. So e raised to log u. That is our e raised to log of u is log of x. Okay, which is nothing but log of x. This is our integrating factor. Next question, you have to integrate this. So looking at the question, you will find that you have to use trigonometric formulas, okay, identities. So first thing is, here it is given sine raised to 8 and cos raised to 8. So if I take it as sine square x minus cos square x, okay, then we can use the algebraic identity a square minus b square. So I can write this as cos, say, not cos, sine 4x square minus cos 4x square upon 1 minus, here also we can substitute something. 1 we can write it as sine square x plus cos square x the whole square. Because here the term 2 sine square x into cos square x is given. So we can make use of the formula a minus b the whole square. Okay, this is 2 times a into b. Okay, so this becomes, using algebraic identity, we can write this as sine 4x plus cos 4x into sine 4x minus cos 4x. Okay, a plus b, a minus. Here, if I expand this, we'll get sine square x plus cos square x plus 2 times sine square. Okay, this will be sine 4x, not square, because this is a square here. Sine square x into cos square x minus 2 sine square x into cos square x. So this gets cancelled. Dx, dx. This goes. Okay. This also becomes 1 by using the identity sine square x plus cos square x is 1. Right. So this becomes 1. This also becomes 1. Only thing remains is sine raised to 4x minus cos raised to 4x, which I can write as minus cos raised to 4x. Okay, this also we can reduce. Again, we can take the same formula, sine square x minus cos square x. So this I can write square, 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 square. Okay. So sine square x, this you can cut. Okay. This 2 gets cancelled, then this 2 gets cancelled. Only thing remains is this term. Sine square x minus cos square x into sine square x plus cos. Again this becomes 1. Only thing remains is sine square x minus cos square x. So we have a trigonometric identity which says, if I take minus outside, then this becomes cos square x minus sine square x, correct? Which you can write it as minus cos square x minus sin square x is cos 2x. So integration of cos 2x is minus sin 2x and derivative of 2x is 2. Let's see. Okay. This is plus, okay. Integral of cos is sine and integral of sine is minus cos. So this is minus sin 2x upon 2. Let's see.